Now this illustration illustrates heat generated internally due to the calculated load in accordance with NEC 310.14, A as in Apple 3, informational note 1, using this item number 2. Now, notice we have a connected load of 37.5 amp, single phase, and it's a continuous duty operational type load. If it's a branch circuit, we're sizing those conductors in accordance with 210.19A1A to determine load. If they happen to be feeder conductors, then we'd be using 215.2A1A to determine what the load would be. Now notice in the quick calc above, we have 37.5 connected load times 125% for continuous operation, continuous duty, we come up with 47 amps. The calculated load now is 47 amps. Our conductor now has to be sized with a ampacity to carry the 47 amps at 60 or 75 degrees C terminals as marked at the circuit breaker and the equipment in accordance with 110.14C. The overcurrent device then is sized by the section number 210.20A. The conductors is brought along at 125% to derate the loading of the overcurrent device 80%. And that's what this illustration is showing. 240.4 A through G applies to the overcurrent device. It's selected from table 240.6A in accordance with 210.20A and B, as you see in the illustration. We're protecting the equipment now with the overcurrent device at the service panel in accordance with 240.1, 240.3, and 210.20C. Now, the sections that you see listed there should be reviewed so your knowledge on heat generated internally based upon the loading of the conductor in accordance with 310.14A3, informational note 1, item number 2. That's what this figure 8-3 is illustrating, taking a connected load, multiplying it for continuous or non-continuous load. The 3-hour or more requirement that a load is considered continuous if it's used for 3 hours or more is defined in Article 100 of the NEC.